Okay. So coming to the evolution of electronics. Evolution of electronics is mainly through three key components. That is the initial invention in the electronics. The first invention in the electronics is vacuum tubes. Vacuum tubes. And later on, the transistor is developed. After the transistor, the integrated circuits are developed. The vacuum tube is developed in the years 1905, whereas the transistor is developed in 1950s, and the integrated circuits start developing in 1965 onwards. So this is the evolution, start of the electronics. So vacuum tubes started in the year 1904. So these are the pictures of vacuum tubes. Okay, these vacuum tubes which are having the electrodes, the metallic contacts we can visualize. These are called as electrodes. So vacuum tubes are the electron valves were invented in 1904 by John Ambrose Fleming and served as a basic component for electronics throughout the first half of the 20th century until the invention of transistor, that is 1950s. Up to 1950s, these are used as electronic components. No other components are present like ICs, chips. Okay, those are not invented before 1950s. So applications of these vacuum tubes include the radios, olden radios, television, radars, sound recording system, large telephone networks, industrial process control, and the first generation computers also used these electrodes, vacuum tubes. So how these vacuum tubes generate the electron flow or the small electron current? Okay, that is by means of thermionic emission. So the operating principle of vacuum tube is based on the process of thermionic emission. So how this emission occurs? Vacuum tubes involve the transfer of electrons between the electrodes. The energy required to overcome the forces holding the electrons is supplied by direct heating. How the electrons are start moving freely means by means of heat. That is nothing but thermionic emission. With the help of heat, they will generate the electrons. These electrons will be made as in an ordered way. They will move in an ordered fashion. Then only it will call it as flow of electrons causes current. If the electrons are moving in arbitrary directions, it will not form a electron flow or the current. Okay, so to make these electrons as in ordered fashion, we'll use cathode as well as anode. We know that cathode generate the electrons and anode will attract those electrons so that it will move in one certain direction. It will cause the flow of electrons or the current. So at a sufficient high temperature, some electrons will have enough kinetic energy to escape from the surface of the material. These escaped electrons then become the core reason of how a vacuum tube works. Okay, in the next slide, here we can observe how the electrons will flow. So in this picture, you can see or you can observe where the heating element is there, like our water heater, not the geyser, water heater. If you immerse that water heater into the water will heated. Okay. Likewise, in the middle layer generate the heat. So around that there will be a electrode. The electrode means the material which contains the electrons. These electrons have sufficient energy to break the covalent bonds and move in a arbitrary fashion. Okay. So if you place a anode, see the black line here, this layer acts as the anode. The copper color, you can observe the cathode here. Okay, heated cathode. The heated cathode generates the electrons anode attract those electrons. Okay, so this setup will be placed inside a glass, as we have seen in this diagram. Okay, inside that glass, there will be a anode, cathode, heating element, everything are placed in this glass vacuum tubes. Okay. So vacuum tube is a sealed glass tube containing vacuum which allows free passage of electric current. The cathode is the electrode that contains the heating source from which electrons are released. The anode is the electrode that receives those electrons, thus providing an electric path in the tube. Okay, so this anode, due to this anode only, the electrons will be flow in certain direction. Whenever the electrons achieve certain direction, it will cause the current flow. It will cause the current flow. As we have discussed, the electrons, if the electrons moving in arbitrary direction, then it won't make any flow of electrons. Okay, so electrons always need a path. Okay, path or direction, then only it is called current. So the grid is an additional electrode by which the current flowing in the anode circuit can be controlled by another potential. So all the electrons which are coming will not cause the current flow. Based on the grid will absorb some of the electrons and some electrons will be attracted by this anode. So current also controlled by based on the grid. If you want only 2 amps of current, the remaining electrons which are generated by the heating up, that will be absorbed by this grid. Okay, that is a controlling action will be taken by the help of grid. So there are a lot of disadvantages with this glass vacuum tubes. Okay, glass is the one of the drawback. It is a fragile element. Whenever it is fall down, okay, it will be broken. So when compared after the invention of transistors, so semiconductor devices are invented in 1940s. The use of vacuum tubes was gradually replaced by transistors. So when compared to transistors, vacuum tubes have several drawbacks. Large size is one of the drawback. Due to that reason only, the first generation computer is look like our occupy the size. The size of the first generation computer is like our home, 4 rooms home. Okay, that is the size of the first generation computer. So large size of vacuum tubes is one of the drawback. Higher operating voltages and less efficient, and glass tubes are fragile, higher cost, and needs regular replacement. Whenever the filament is blown, how the heating is generated due to the filament. Whenever the filament is blown, we need to replace that vacuum tube again. Okay, so needs regular replacement. These are the drawbacks with these uh, vacuum tubes. So some applications are still using these vacuum tubes. Examples are cathode ray tubes, CRT cathode ray tubes in the video monitors, but those are also eventually suppressed in the 21st century. The olden TVs, not the LED TV, before that cathode ray tube TVs, olden TVs uses cathode ray tube. Okay, you can search in the internet also. CRT monitors. Okay, you can visualize the examples. Okay, so the base for invention of vacuum tubes also the scientist Thomas Alva Edison. So with this Edison effect only, vacuum tubes are invented by Fleming. Okay. Thomas Alva Edison discovered the electrons will flow from one metal conductor to another through the vacuum. That is called Edison effect. Is the John Fleming applied Edison effect in the invention of two-element electron tube called vacuum diode. Vacuum diode. If the vacuum tube having two elements, then it is called vacuum diode. If it is having three elements, it is called vacuum triode. Triode. Triode means number of metal contacts or metal or Okay, number of metallic contacts, 2 element, 3 element, like that. Diodes, triodes. So this scientist developed a 3 element vacuum tube called vacuum triode. So this was the real beginning of the electronics. So many electronic applications uses transistors. Okay. Only diodes are used for electronic switch. Very less applications of diodes when compared to transistors. So after the invention of vacuum triode only, the real electronics journey was began. Okay. So Marconi, scientist Marconi invented a radio, which was the primary form of the education and entertainment radio. Okay, this setup we can see how the radio, first generation radio. So after the vacuum tubes in 1947, the transistor was invented by John Burdine, Walter Bretton, and William Shockley in Bell Laboratories. Bell Laboratories. Okay, the invention of transistor revolutionized the electronics industry due to its features such as lightweight, low cost, less power consumption, and reliability. Okay, it will last for long years, years and years. Some electronic devices like our keypad phones still they are working. Okay, so which reduced the size of the electronic devices. The another breakthrough happened in 1956 in Bell Laboratories invented thyristor, that is silicon controlled rectifier. So in 1958, Jack Kilby, an engineer of Texas Instruments, demonstrated the first IC. IC means integrated circuit. Integrated circuit means, as the name indicates, integrate, which integrates many electronic components inside a small chip. Okay, integrated chip. So large number of electronic components could be fabricated together on a single chip. So beginning of microelectronics revolution starts after the invention of ICs, integrated circuits. So in the year 2000, Jack Kilby won the Nobel Prize in the physics for miniaturized electronic circuits. Miniaturization means reducing the size, compact in size. Okay, our cell phone evolution or computer evolution, if you observe, the 4-room size to a smart tab size of computers also available. Okay, that is called miniaturization, reducing its size. Miniaturization means reducing the size. So this is the first generation integrated circuit. Okay. So as the technology advanced, number of components fabricated on a single chip also increased. This advancement in chip fabrication is accordingly called small scale integration. SSI represents small scale integration, medium scale integration, large scale integration, very large scale integration, ultra large scale integration, etc. Okay, so this resulted the new era of computers, mobile phones, and microprocessors. 4-bit microprocessor was developed by Intel in 1971. So microprocessor means every electronic device, smart devices contains some processor, Okay, in the advertisement also we'll see Intel processors. Okay, so these processors are very much essential in the laptops, mobile phones. Our mobile phone also consists of processors, right? Snapdragon, quad core, okay, processors. They will advertise like that. While purchasing a mobile also, we'll check the features like processor, RAM size, ROM size. RAM and ROM are the memory types. Memory types. Okay. So this is the identified the evolution we can observe in this chart. So for vacuum tubes, first generation. Transistor is the second generation. ICs are the third generation. Small scale integration and medium scale integration, large scale, very large scale. Up to the very large scale integration, simply we'll call it as VLSI, very large scale integrated circuits. So fourth generation. Ultra large scale integration is the fifth generation. Okay. So these are called generations in the electronics. Okay. Whereas in the computers, first generation computer, second generation computer, third generation computer, fourth generation computer, like that. In the mobile telephony technology, we are using now 5G technology. So in the mobile evolution also 1G technology, that is analog telephone, 2G technology. 2G is completely digital. 3G technology, 4G technology, 5G technology. Okay. So those are the generations. Our 5G also fifth generation mobile telephony. Okay, these are the generations. So what is the impact? We can, without knowing any knowledge about electronics also, we can imagine. Okay, what is the impact of electronics in the modern world? Everything is smart devices. Smart devices contain some embedded systems or the IoT, Internet of Things. Those technologies are introduced. So electronics becomes our part of our life made easy in several ways. Okay, like our Amazon's Alaska. Okay, and many features, many software evolution, many devices are evolved. So 21st century rely on the electronics. Electronic technology is employed in the field of industry, communication, military, entertainment, education, automobiles, etc. So in fact, it is difficult to find an area where the electronic technology is not applied. Okay, like our AI that is evolving, like electronics also, which are present in almost all the industry areas or industry domains, working domains. Okay, everywhere we are using the electronics. So electronics in these are some of the applications: telegraphy, telephony, fax, radio communication. Okay, televisions, cable TV, that set-up boxes. Those are also electronic device component. Mobile communication, internet or social media we are using. So teleconferencing platform, video conferencing, Bluetooth, Wi-Fi, music players, public addressing systems, television programs, social media, video games. Okay, all these are become our part of our life. Electronics is applied in the area of medical field also. So electronic equipment such as ECG, EEG, artificial pacemaker, electronic sphygmometers and heart lung machine, laser based surgical equipments, scanning equipments like X-ray, computer tomography, MRI, ultrasound, nuclear imaging, telemedicine also. Now it is very famous, telemedicine. So surgeries also making by means of these video conferencing also, telemedicine, telegraphy. The electronics in instrumentation. Okay, our laboratory equipments, most of our laboratory equipments are electronic devices. So CRO, cathode ray oscilloscope, which is the display device, waveforms we can observe on the CRO. Function generator, the sinusoidal, triangular, square wave will be generated by means of these function generators. Digital storage, DSOs, distance storage oscilloscopes. Okay. Fingerprint security systems, drones in air traffic control, multimeters, strain gauges, CCTVs, microwaves, air conditioners, induction heaters. Okay, all these are in the instrumentation. So electronics in defense. Okay, very much familiar. Radars, radar tracking, okay, missiles, rocket launching, sonars. Okay, sonars are used for detecting the sound waves in the underwater also, seas, underwater. Radars, we know when unauthorized aircrafts are moving from borders, okay, can be detected by the radar. Okay. So these are the applications in of electronics.